Welcome to this week's Property Elite podcast. Stay tuned each week for industry hot topics, market updates, and new RICS guidance.
Hello, I'm Jason Ratcliffe, the Wellbeing Surveyor, and I see homes through a wellbeing lens. Today, I'm going to be reading the blog that I've written, The Invisible Performance of Buildings. Why what you cannot see often matters most. When we think about buildings, our attention is almost always drawn to what we can see. Cracks in walls, staining, movement, defects in finishes. These visible signs tend to shape how we assess condition and performance. But in reality, the true performance of a building exists largely beyond the visible. Air is constantly moving through and around the structure. Moisture is travelling in different forms, sometimes slowly and sometimes rapidly. Heat is being gained, lost, and redistributed. Materials are interacting, not just physically, but chemically over time. These processes are continuous, dynamic, and often completely unnoticed. It is within the invisible layer that many of the most important building failures begin. For those entering the built environment, particularly students and early professionals, understanding this hidden performance represents a fundamental shift in thinking. It moves you from simply observing buildings to truly understanding how they behave. A useful place to begin is with a simple but powerful question. Can a building fail without looking like it has failed? The answer, more often than not, is yes. A wall may appear perfectly dry, yet internally hold elevated levels of moisture. A room may feel comfortable in the moment, yet be poorly ventilated over long periods of time. A property may meet regulatory standards, yet still create conditions that are not supportive of occupant health. This is where the limitations of purely visual inspections become clear. What we see is often only the outcome, not the cause. The real story sits beneath the surface, within the movement of heat, air, and moisture through the fabric of the building. Once you begin to look beyond the visible, the next question naturally follows. How does moisture actually move through a building? Moisture is rarely straightforward. It does not move in a single predictable way. It can travel as liquid water through leaks or capillary action. Within materials, it can exist as vapor, moving through diffusion. It can also be carried by air movement, passing through gaps, junctions, and imperfections in the building envelope. Crucially, it can change state depending on temperature conditions. This is where the concept of condensation becomes far more than just a surface level dampness. When warm, moisture-laden air meets a colder surface within a wall or a roof structure, condensation can form internally. This may occur entirely out of sight, slowly building up over time until it eventually presents as decay, mold, or material failure. At this point, building physics stops being abstract and becomes something tangible. You begin seeing how individual elements such as insulation, ventilation, and material choice interact in real conditions. This leads to a broader and more challenging consideration. Are we truly designing buildings, or are we attempting to predict how they will behave? Design intent is often clear. Ventilation strategies are specified, insulation levels are calculated, and materials are selected based on performance data. On paper, everything is aligned. However, once a building is occupied, its behaviour becomes far less predictable. People live differently. Windows are opened or kept shut. Heating patterns vary significantly. Furniture is often placed in ways that restrict airflow. Moisture is generated through everyday activities such as cooking, washing, and even breathing. What emerges is a gap between design and reality. A building that performs well in theory may not perform well in practice if it does not align with how people actually use the space. This is not a flaw in design, but a reminder that benefits are lived environments, not controlled systems. It also highlights another critical issue, particularly in the context of retrofit. What happens when we improve one element of a building without considering the system as a whole? This is where unintended consequences often arise. Improving insulation without addressing ventilation can increase the risk of condensation. Replacing windows without maintaining adequate background airflow can trap moisture within the building. Applying impermeable materials to traditional breathable structures can disrupt long-established moisture balances. Each change, however well-intentioned, alters the internal dynamics of the building. Buildings do not operate as isolated components, they function as interconnected systems, where adjustments in one area influence conditions elsewhere. Recognizing this interconnectedness is essential for making informed decisions. As this understanding deepens, the conversation naturally shifts beyond the building itself and towards the people within it. Can a building affect how we feel without any obvious cause? The answer again is yes, and this is where building performance and human well-being intersect. Indoor environments are shaped by a combination of air quality, humidity, temperature stability, and the emissions of materials within the space. When these factors fall out of balance, the effects on occupants can be subtle but significant. People may experience fatigue, respiratory irritation, headaches, or disrupted sleep. These symptoms are often difficult to trace, particularly when there is no visible issue to point towards. There may be no visible mold, no obvious defect, and no clear single cause, yet the building itself may still be contributing to the problem. This raises an important consideration for the future of profession. Are we only assessing buildings in terms of structure and material performance, or are we also considering how they support human health and well-being? To answer that question effectively, we need to expand how we investigate buildings. How do we measure what we cannot see? This is where advancements in construction technology are beginning to reshape the industry. We are no longer limited to surface-level observations. Thermographic imaging allows us to identify temperature variations and heat loss pathways that would otherwise remain hidden. Indoor air quality monitoring provides insight into pollutants, ventilation rates, and overall environmental conditions. Moisture measurement and in situ testing enable us to understand how conditions change over time, rather than relying on a single moment of inspection. These tools do not replace professional judgment. Instead, they strengthen it, providing evidence to support or challenge our assumptions. For students, this represents a significant opportunity. The ability to interpret and apply this data meaningfully will become an increasingly valuable skill. This brings us on to a final defining shift in mindset. Are we training ourselves to observe buildings or to investigate them? Observation will always be important. It forms the foundation of understanding, but investigation goes further. It asks deeper questions. Why is this happening? What conditions are driving this outcome? How are different elements interacting over time? When you begin to approach buildings this way, each property becomes more than just a structure. It becomes a dynamic system to be understood, explored, and learned from. This approach is not limited to experienced professionals. It can begin at any stage. Sometimes in buildings, notice how they feel at different times of day. Pay attention to temperature differences between spaces. Look for patterns in condensation or airflow. Consider how the occupants are using the environment. Even simple tools can begin to reveal what the eye cannot see. More importantly, curiosity and critical thinking will always be your most valuable asset. The direction of the industry is clear. There is a growing recognition that compliance alone is not enough. Buildings must perform in real conditions, support occupant well-being, and respond to environmental challenges in a meaningful way. For those entering the profession, this presents both a responsibility and an opportunity. An opportunity to move beyond checklists and towards genuine understanding, an opportunity to connect building science with human experience, and opportunity to make the invisible visible. Every building is telling a story, not through what it is immediately seen, but through how it behaves, how it responds, and how it feels to live within. The question is whether we are prepared to listen.
Thanks for listening to this week's Property Elite podcast. Head to our website to check out the full blog, and here you will find free and paid support resources and services. We offer a free consultation for every single RICS APC and Associate RICS candidate, or you can ask us any questions you have via the online chat. See you next week.